Thank you. I feel privileged to be here. You probably heard a lot of people say that accessibility is important. I'm about to explain why I think it's important from the security point of view. I'm here to explain how accessibility is misunderstood and misinterpreted, and how accessibility and security have a lot of common enemies, issues, and problems, and how it's worth looking at in security terms. So before we start the talk, I'd like to get into the terminology. I'm not going to talk about accessibility in the real world. I'm going to talk about the usability of digital content for disabled users. And I will mostly be referring to blind users and screen readers just as an example, because I think that the problems they face have the same sources, even though the symptoms might be different, most of the time anyway. In one slide, accessibility tools need to figure out what's in the document. They need to determine the structure of a document and then to derive its content. So this is about parsing of your digital content. Many security issues are also about parsing of the documents. And if you have a document format that cannot be easily parsed, then the first people to notice it are the accessibility community. The security problems will likely come next. What else do accessibility people have problems with? With executable content. Of course, a lot of security issues also stem from executable content. And accessibility also suffers first when executable content is encountered. Let me start with discussing the current issue of internet and security. So there is basically nothing secure on the web anymore. This didn't happen overnight. Maybe somebody in this room still remembers the Good Times hoax, the email message that went around saying not to open any email messages with the subject Good Times because they will do bad things to your computer. And we got to laugh at people who believed it, because back then, email was text, and text could not do bad things to your computer. Some years pass, and this is no longer the case. Well, let's skip 11 years ahead. 11 years later, some smartass wrote a document which we were happy to distribute, which was titled, MS Word is not a document exchange format. That was just the start of the executable content being distributed for just about anything. And back then, Microsoft Word was the worst of it. It contained all the worst stuff. It was horribly abused by all kinds of people who wanted to do bad things. So the year is now 2012. And my dad has the bad habit of coming to me and asking me if it's safe to open an email, which is probably spam, or a PDF file, which came from an unknown source, or a web page, the link to which came from an unknown source. And all I can tell to him is that nobody knows. It's impossible to check. Nobody can possibly know. From the point of view of theory of computation, it's impossible to find out if it's safe. The year is now 2012, and a bank where I had an account from '93 demanded that I sign up for electronic banking, and they only support 2 web browsers, because they don't know what will happen if I use their content with an unapproved web browser. Where we cannot trust other people's content, and we cannot trust other people's user agents, because our content is so complex that we don't even know what other people's user agents are going to do with it. Well, I'm not a historian, but I think this started with HTML email clients. There is this ASCII ribbon campaign against HTML email, which started in '98. Obviously, they lost. Against them were all kinds of e-businesses that were interested in making everybody look at the pretty pictures on their documents. face it, normal humans generally don't want to format their email in HTML. Well, sure, there are all kinds of mail editing clients which allow you to insert HTML formatting, but mostly people just want to exchange text or documents. They don't want HTML formatting. It was the businesses that started it. Then, of course, the feature bloat. Suddenly, everybody wants it to be possible to include everything in the kitchen sink into their documents, everything up to animations. And so they design a format that you can put absolutely anything into. And guess what happens when your browser has to execute it, right? So we end up with email that's not safe. It needs to display HTML, it needs to run executable content, it needs to open any file, or people will complain. And yeah, it doesn't make coffee yet. That machine is not real yet. But I've heard stories of coffee machines already being on the internet, unverified. But maybe that's coming soon too. You cannot possibly know. So what does accessibility have to do with that? Accessibility is also about parsing documents. And these are the first people who are going to notice and to sanity check your document formats. And when you create a web page only for a handful of web browsers that can read it, they're going to come by and they're going to attempt to let it be read by a screen reader. And they're going to suffer, but they're not going to complain because they don't really expect screen readers to be, they don't really expect anybody to account for screen readers parsing their document. There are all kinds of guidelines, but there are no standards. They just have to do their best in the face of the absolute lack of any guarantees. Then there is the real world, and the real world is ugly. So this is from the bottom of a conference talk submission page. This is read in links. I found this and I didn't know what it was. So I had to load this in a real browser. And it turned out to be a Google CAPTCHA, which is kind of interesting because you see the audio button there. So they implemented the accessibility feature. Technically you can get to the audio CAPTCHA for this, but it's hidden in JavaScript. You can't search for it, you cannot tap to it. Apparently the same is true for the audio replay button. Let me note that I'm not trying to pick on any particular vendor. I'm not trying to pick on Google or on Adobe because accessibility is a very difficult problem. But sometimes you really have to wonder what on earth they're doing. Oh, there is a no-script version of the same page. It looks beautifully accessible. But for some reason, they recommend to turn JavaScript back on when you go there. In a bit, we will discuss this mystery. We will find out what exactly they were doing here. Oh, another Google example. So did you know that if you use the Linux web browser, you're not going to be able to rerun the search from the page it takes you to? Because this web search, this is not actually a link. This is some kind of JavaScript. And if you hit enter, you'll notice that it says text field name Q. It doesn't submit it. So when you hit enter, it goes to images and it does an image search for you, which is going to do you a lot of good in the text browser. In the real web browser, like I already said, this is JavaScript. If you have JavaScript on, it works. If you have JavaScript off, you're not going to be able to use this link. Over there on the right is something that didn't make it into the screenshot, because it's really hard to take a screenshot of a Google page. Apparently, over there is this cached version, the link to the cached version visible on mouse over. I know a computer science professor who is a brilliant researcher and who said it took him 3 months to find out where the cached versions of Google cached pages were now visible in the current search. He's not in any way disabled, and he's very literate, but apparently this is done for somebody else. Another example is PDF. It's no secret to anybody that PDF has had its share of security vulnerabilities. The MITRE database of common vulnerabilities and exposures, which was created in 2000, has CVEs dating as far back as its creation date. Some of them are about parsing, some of them are about executable content. Years passed. In year 2010, Julia Wolf read through the entire PDF format specification and gave her talk, "Oh my God, WTF PDF," which examines the PDF format and which shows that it contains, well, pretty much absolutely anything you can think of. That in order to read a PDF file, you're supposed to be able to parse JavaScript and XML, render OpenGL animations, that there are 15 million lines of code supporting this all. Well, those 15 million lines of code also include embedded Flash, but that is still a bit too much, right? And you can imagine the number of bugs in that body of code. There is also no specification for validating compliance of readers or validity of files, and there are some really bad format ambiguities. My favorite one is where a PDF file can also legitimately be another kind of file, because the PDF header can be in a different place than a normal file header. So you can have a PDF file that's at the same time a zip archive. In year 2011, Andreas Bog is working on verifying a PDF parser, and he ends up with a file that crashes every PDF viewer he has. And probably some PDF viewers he doesn't have on his laptop. This bug has been filed for events. I have not been able to find out what other PDF viewers it has been filed for, or which files, or which viewers it has been fixed in. The PDF file is filed at the events bug, so it's accessible to everybody. And there is an infinite loop that you can generate in the file. And this is probably a bug more in the format than in the PDF viewers, but they're going to fix it in the PDF viewers, because you cannot just go and fix the format. Well, Adobe can kind of handle PDF. Apparently, Google cannot. So this is just from the year 2011. There are a couple dozen of CVEs in the MITRE database. They all have the same form. Google Chrome incorrectly handles this, and this, allowing remote attackers to cause a denial of service or unspecified impact. Year 2012, they got smarter. Now they actually combine different vulnerabilities into the same bug report. Some of those CVEs have as many as 16 links to different bug reports in them. So there are 43 CVEs referring to PDF and Chrome and Surge, but in particular there are probably hundreds of actual bugs. That's the sound of Google having trouble parsing PDF. What about accessibility? We all heard many times that PDF is an accessible format. Just ask Adobe. And at some point they implemented tagged PDFs as this greatest accessibility PDF feature ever. They created an accessibility checker that checks for tags, and everybody loves tagged PDFs. And sure, so the documents that describe how to create an accessible PDF are up to 15 or 20 pages. And there are people complaining all the time. And they're always told that the mistake is that they checked some option wrong or clicked on the wrong button somewhere. And that's why they ended up with a PDF that is not as accessible as they would have liked. But generally, everybody is happy, and there are always user mistakes, and there are always bugs, and that's all normal. You wouldn't notice that anything is at all wrong, or would you? In the year 2010, a company that's not Adobe decides to implement a PDF accessibility checker to compete with Adobe's accessibility checker. So they publicize it, and they also publish a comparison chart. Three rows from the comparison chart. Take a look. This is great. So there are two accessibility checkers, one of them belonging to Adobe. None of them can properly check for incorrect text structures. The second one, so Adobe can detect untagged content. Those people cannot detect untagged content correctly. And they have trouble validating list and table structures. So this is your state-of-the-art stuff, right? They're checking for accessibility, and they cannot parse the PDF files. They cannot figure out what's where. They cannot figure out that things are done correctly. They had all these years to get it done, and they all made attempts, and they failed. And they never told anybody. Because, you know, accessibility people don't talk to security people. And accessibility people don't think that not being able to parse a document consistently is a big issue. They don't have expectations like that. So they don't know how to check PDF structure. And we didn't even get into executable content yet. We just really, so the best people don't know how to find out what's in your PDF document. And they've been at this for many, many years. They've been aware of this. They just didn't tell us. Before I continue, I'd like to get into some theoretical background, which will probably sound trivial to those of you who are in the academia, but maybe some of the others will appreciate it. So the halting problem is the problem of deciding whether a program will ever stop. And it's undecidable. There is no algorithm which solves it for every program. The proof that it is undecidable is so simple that there is a poem where Dr. Zeus explains that the halting problem is undecidable. A very simple corollary of this is Rice's theorem, that there is no general algorithm to figure out what a program is going to do, whether it's going to compute a given non-trivial function. Being the corollary of the halting problem, it's also undecidable. Language theoretic security, introduced by Len Sassaman and Meredith Patterson. The claim is that the current internet insecurity is largely due to incorrect parsing of inputs. And that if you have an overly complicated input data format, then parsing it correctly is as difficult as solving the halting problem. That is, it can't be done. You also can't check equivalence of parsers, and if you are using non-equivalent parsers for the same inputs, then you get security problems. If you're not familiar with this, I highly recommend checking out the link at the bottom of this page, langsec.org. So, accessibility is about parsing. What does W3C have to say about this? Well, W3C has to say a lot of things, and that's part of the problem. Because when there are many pages describing what accessibility is about, chances are that it's really hard to follow through and do something about all of those things, even if you wanted to do that. So this is from the Web Content Accessibility Guidelines version 2.0. So the guidelines are divided into 4 categories. The version 1.0 had 14 categories. But if you think that it's becoming easier to see the forest behind the trees, you might be wrong, because now they've bunched very different things into the same categories and repeated the same things or things that look like the same things to you in different categories. So I'm going to make a translation attempt to explain what a lot of this stuff is about. First, let me give you some quotes, though, so you can see why we even care, if this is even about the things we are talking about. Look at this. So they want the information available in a form that can be determined by software. So it is about parsing. They may not say the word here, but it is about parsing. And if they have information that is embedded in such a way that the structure and information cannot be programmatically determined, then they cannot convert it into different formats. That is, if you cannot figure out what's in your document, you cannot read it aloud, for example. Oh, there is more. Maximize compatibility with current and future user agents. Tell this to your bank. Now they actually admit that this is about parsing, about having well-formed content that can be consistently parsed, and about having user interface components where the name and role can be programmatically determined. And there's more. Make all functionality available from a keyboard. Tell this one to Google. And more. When any component receives focus, it doesn't initiate a change of context. Tell this one also to Google. And then there is something I really don't like. This changed from version 1.0 to version 2.0. Version 1.0 said that web pages should remain usable if you turn off executable content. Now W3C's policy seems to be that you can make any executable content accessible if you just try hard enough. I'm going to attempt a translation. They're asking for the ability to consistently parse documents, for documents with correct document structure, and for compatibility with different user agents. They're asking people to avoid abusing active content. I wish they were asking people to avoid active content whatsoever, but I guess they've decided that this is not realistic. They're also asking for tags and alternative content, which are good practices, but unless it's required by the format and your document will not open without it, this may or may not happen. And they're also asking for people not to create really badly confused documents with really bad stuff in them, which, like the slide says, you can't fix human nature. So I'm afraid that's not something you can make happen either. I have a waffle maker that cost me $10, and they can't understand its manual. I'm pretty sure it contradicts itself in at least 4 different places. So Google CAPTCHA and Google's reasoning on hiding the audio CAPTCHA under JavaScript. They hid it on purpose. They hid it on purpose because users were tabbing to it by accident. So they decided that they're going to make things pretty by disabling that part of keyboard functionality, and that screen readers will use it just fine because they're using the DOM tree of the page. So let's see. Accessibility is a special interest. It's treated as a special interest here. And the rest of us, well, the rest of us should use a real browser or something. We don't care about how things work for everybody else. This doesn't work so well with W3C guidelines, but I get the impression that nobody really cares. Executable web page content. From the security point of view, scripts can do bad things. And you can avoid some of those bad things by having browsers detect them. But you run into the halting problem. You can't really find out what a script is going to do in all of the cases. Somebody is going to be smart enough and write a script that's not going to get detected by whatever you've written to solve the halting problem. From the accessibility point of view, scripts can also do bad things. They can change focus on you. They can change the content of the page when you're not looking. And you can parse and check for some bad things. But you also run into the halting problem. What's worse, you run into worse than the halting problem. Because before you ban something, you also need to define what it is that you're trying to ban. And if you think that checking what happens to the graphical representation of a page is easy, you ought to try it yourself sometime. So why do people do this kind of thing? The usual claim is that this is for the sake of user experience, that they do this to get traffic. When you complain, they tell you to get a supported browser or to get a real browser. And then they ask you if you really believe that there is someone out there who doesn't use JavaScript. I'd like to say something about the JavaScript. I think that it being used to enhance user experience, that this is largely a myth. That a lot of times it is used either for entirely random reasons, like in those Google examples, or it is used to push ads on you. Here is what, to everyone's surprise, turned out to be a website that drives most news website traffic, more than Facebook, more than Twitter. So this is from a survey from 2011. On the right are the percentages of traffic driven to news websites from Drudge Report, Facebook, and Twitter. What is Drudge Report? Well, this is something that's written in the Stone Age HTML by 1.5 developer. So it's written in 3 columns. It doesn't have any executable content that's not ads. It loads just beautifully in everything, including links. All right, and the content starts just below the header whereas if you're trying to get to Google News, for example, and you have 40 rows on your screen and are using links, it will take you, the content will start on page 4 for you. And if you're trying to get your recipe from Food Network, then the title of the recipe is on page 11, and the recipe itself starts on page 14. So the good guys, the bad guys. This is pretty amazing, actually. This is even more amazing than it looks, because this website, which is Google News, actually actively resisted my attempts to take a screenshot. I tried to resize it to fit into my screenshot, and when I resized it, this left column would go away. What's more, there are elements which are only visible on mouse over. For example, there is the scroll bar over here, which did not fit into the screenshot because it's only visible on mouse over. As I already mentioned, so there is a lot of junk content on top of the page. There's this long list of additions. So if you're using links to read this, there are 3 screens before you get to the content. Lest you think this is just Google, almost everybody else does the same thing. I absolutely love all the subscription options showing up on top of the page, and all the possible error messages for when you're trying to access something that you don't have access to. This is some local newspaper, Milwaukee Journal Sentinel. All the subscription options, 15, 5, there were more below there, it didn't fit. Okay, so this one absolutely drives me nuts. I don't know why this is broken. I tried to figure it out. So below is the links representation of that web page. On the top, it is in a normal web browser. On top, it has a search bar. On the bottom, it does not. You don't need a search bar for a dictionary, right? So you just read the entire thing from cover to cover. So the state of accessibility. They have a lot of same enemies with security, but they just don't talk the same language. And all those well-meaning people who try to create accessible pages, they often treat it as a special interest. Developers of accessibility software are also not used to people doing things correctly. So they just try to make their software work almost always. They're not expecting anybody to do the right thing. And then there is also the user feedback problem. Have you ever tried to get a blind person to explain to you what he is not seeing on a page? This is quite possibly a really large part of why bug reporting is so bad with these things. Because users are really bad at reporting the things that they do not see or cannot access for another reason. What can we do? We can start thinking about accessibility and security terms. We might be able to call out the worst offenders and to ask them to stop doing the worst things that they're doing. Also, when somebody claims that they're doing bad things for the sake of better user experience, you might want to think whether this is really correct, or whether they're doing it for their own benefit, for pushing ads on you, or just because somebody on their development team has really weird ideas about how things should look. I'm also thinking that we can't make people care about security, but maybe we can make them care about accessibility, right? Because this is about real people. This is about live people who are not guilty of anything. They just have their problems. And, well, try to do the right thing and casually sanity check other people by, say, using links or something like PDF to text. And one more thing, remember the halting problem. Learn to notice when somebody is selling you a solution to the halting problem. Realize that you cannot check that the program is safe to run, or that a complicated file is safe to open, or that a web page or a complicated file is accessible. This cannot be done. And if you have any ideas about what we can do to fix the current situation, please let me know. Thank you for listening.